Hi everybody. Today's little video is answering the question, why does the same note that's played on a guitar and a piano sound different to your ear? So even if you're not in the room and there's all these musical instruments in that room, and someone strikes, let's say, the note A, which is 440 hertz on a piano, and someone plays the same note on a flute or a guitar or some other musical instrument, you can tell even without actually seeing the instrument that it's played by different instruments. So this little video is to explain why this happens. This all has to do with the characteristic of every instrument, and the characteristic of the tone produced by the instrument is what we call timbre, and that is what gives that richness to each musical instrument. Okay, so in order to explain this, the tuning fork, which I don't have in my hand here at home, but we do have some in the lab, it looks like this. It's got two prongs, and the tuning fork, and the way that you produce a sound with a tuning fork is we strike the tuning fork against a rubber bung or something, and what happens is that the prongs vibrate back and forth, producing a sound. And these are the only instruments that produce pure notes. So if we had an oscilloscope or something which could record the note that's produced by a tuning fork that's vibrating, the shape of the note will look like this. These are pure notes, just the one's frequency. Those are the only instruments. So what happens to the others? So let's say both guitar and piano are stringed instruments, and let's say these are strings fixed at two ends. So that's a string, there's the two ends, and there's your string. That's your string. The fundamental, if you strike a note on a guitar or a piano, what happens is, in addition to the fundamental, so your fundamental looks like this. It's not just the fundamental that's produced, it's a whole lot of overtones. So you have that fundamental, and then you have multiples of that fundamental. So in addition to this, you might also get a smaller amplitude of the first overtone, and you might also have the second overtone, maybe different amplitudes, and you could have third overtone and so on. So and each of these overtones have their own a different amplitude. So if I draw a graph of the note that's produced by the guitar, this is your guitar and that's the amplitude, and it's all A. You could have note A would be the highest amplitude, and that is 440 hertz. But in addition to that, you would have the next one, which is 880 hertz, which is maybe a smaller amplitude, and you could also have the next higher one, which is 1320 hertz. And then so you have these overtones which are exact multiples of the fundamental. They are produced as well, and the note that you hear is a combination of all this, but the amplitudes of these are different. So the shape of the wave that's produced is not simple like this, but it might be something like this depending on the different amplitudes of the different notes. Piano as well. Also, if you play the note A, we'll also have your 440 hertz, which is your fundamental, but the amplitudes for the different overtones is different for the piano and different for the guitar. So when they add up, the shape of the wave that's produced, it's quite different, and that is why they sound different. So the amplitudes of the higher harmonics are different for every instrument, and that's what gives them their characteristic sound. Okay, so that's how you explain this question. So the main note, the fundamental, is overlaid with harmonics, and the amplitude of these harmonics are different, giving each instrument its characteristic note. So I hope that made sense. Bye for now.